What is young Earth science? Yes. And how does philosophy relate? Should we waste billions on funding research based on old Earth fallacies? How does young Earth science relate to public policy issues like school choice and government funding of research? That's from Jay.
Hello, Jay. How you doing?
We're doing real good. How about you?
Good. There's one thing I really like about the young Earth theories is that relative to the age of the planet, it makes me feel a lot younger
Ah,
to have a significant percentage of the age of the planet tucked under my aging middle-aged body. But how you doing tonight?
oh, we're doing well. Thank you.
All right. So, do you want to take the questions one by one? Do you want to make a pitch for the young Earth thesis? What's your pleasure?
I'll take the first question. In terms of a general philosophical perspective, like what we come to the table with, either from our background, how we were raised, our general worldview. I think it was Time Life books introduced me to the idea that the world was billions of years old. So I just accepted it. You know, these were the sort of things I saw at school. This is what my teachers were telling me. So I go with that. So the important of kind of a starting point, what do we assume? What do we start out as? And my history of science professor was David Kitts. He studied under the well-known paleontologist G.G. Simpson. And he gave me an interview, and he basically said that the reason when we look at the fossils that we assume that evolution is our starting point. So kind of the idea that we have to look at assumptions and worldview and where that comes from. And one thing I looked up was a current book on evolution. It was called Randomness in Evolution. And I just searched for key terms like presume and assume and guess and things like that. So that's one aspect that I think is
Okay,
really
I'm sorry,
important.
I got to interrupt you here. And you have the typical mentality of somebody who's well versed in a discipline who wants to start halfway through for people who don't know what you're talking about. Okay,
Okay.
so the young Earth thesis or hypothesis, I guess we should say, is that for a lot of people, it's around that the world is 4,500 years old. And I assume that this, of course, has to do with the biblical creationist story. I think it was in the 18th century where somebody looked at the generations that are described in the Bible and worked backwards and figured out how old the world was. And that's given kind of an ancillary argument that if you start with Adam and Eve and double the population every 150 years, you end up with something similar to the current world's population. And so that is the general thesis, that the world is a few thousand years old, was created by a god, and that is a defense of a theocratic worldview or theocratic universe. And that's sort of I just want to give people the general overview before we delve into the details. Is that a reasonably accurate way of portraying the approach?
Well, in my book, yes, Young Earth Science, what I do is I try to defend a young Earth from history, from philosophy, from geology, biology, and physics. And two philosophers that actually had a similar viewpoint would be David Hume and Lucretius. David Hume looked at Columbus and wondered, well, haven't there been other Columbuses before? And then he gave the funny example of like garters to hold your socks up. As technology progresses, we kind of extrapolate it. So if we're at this point, like when I was reading my weekly reader in school, in grade school, they said we'd all have, flying helicopters by now. We haven't. But the point is, over time, technology increases. So it kind of gives us a hint that, well, maybe man hasn't been on the earth that long. And Lucretius, he referred to Homer and said, why aren't there stories of maybe, say, the Neanderthals and all the fantastic things they did? How come we don't have lots of stories before Troy? And he mentioned the Theban Wars as well. And so basically what I'm using is a straightforward argument using an omnicultural approach where I use history and science to argue that the world is thousands of years old and not billions, which is the current consensus.
All right, good stuff. And which one do you want to take on first? Which aspect of the proof?
I would make a number of arguments. So if we look at different cultures that considered time and kept track of their records, a lot of the civilizations, especially if you keep it to, say, the ancient king lists, where you can kind of connect them up, kind of like what you were suggesting, is that most of the cultures started around 2500 BC, and then bringing it home to the Americas, there was a scholar who wrote a book about earthquakes, and then he also discussed about Mesoamerican traditions. And there was a writer who was the great-great-grandson of a Aztec leader. And if you take those dates, you kind of have to tie it to the beginning of the Toltec period. You come up with that their understanding of when the beginning was somewhere between 3600 BC and 4200 BC. So somewhat similar to the date you suggested.
My knowledge of the term Toltec is mostly limited to a John Anderson album, but I'm not sure I quite understand the argument. And again, I'm going to have to interrupt you from time to time because otherwise the questions pile up in my brain and I start to forget them. So, is the argument that because recorded history is only a few thousand years old, that the Earth can't be much older than recorded history? Is that right? Or written history?
Yes, I'm saying that there are some traditions, say as the Sumerian king list, that bring it back to what I'm claiming is the beginning of humanity. Yes, and that there's other reasons to look at the geologic record, which we could get into that.
Okay, no, hang on. Hang on. You can't just give me the avalanche of words, right? This has to be a conversation. This can't just be a filibuster on your side.
Right.
So the argument is something like this, and I'm not trying to paraphrase it. I'm just trying to understand it accurately. So the records of human civilization go back, I don't know, 5,000 years, if you sort of look at ancient Egyptians and so on, right? I guess 5,000 years BC, perhaps. Is the argument that because human beings were created at the same time as the Earth, and there are no records that go back more than 5,000 years BC, that human beings and the Earth must have been created at around that time? Is that right?
Essentially, that's right.
Okay. I'm not sure how that follows. Because, as you know, and I'm not going to insult your intelligence by pretending you haven't thought of these things a lot, right? So I'm just giving you the outside question. I'm not trying to imply that you haven't thought of these things. But I'm not sure how logically it follows that if it takes life 4 billion odd years or 3 billion odd years, I can't remember exactly how long it's been since the primordial soup is supposed to have coughed up the first organism, but if it's taken life a couple of billion years to come up with language, like written language or recorded language, why would it be the case that the time between the beginning of life, according to biologists and so on, that the beginning of life to the beginning of recorded history, why would that not exist?
I'm making the assumption that there may be something to these different traditions that do put the two together, and that that would lead to other assumptions or conclusions rather that, well, then our traditional geological interpretations have to be flawed.
I'm not sure how that answers the question. Sorry to say that.
I'm taking it that I think there's some truth to these ancient myths, ancient legends. And
which ancient myths? I don't know which ancient myths.
Well, the Sumerian king list is where they take the kings from before the flood that the Epic of Gilgamesh relates. So that takes it back to the beginning. And that if you change the math from a base 60 to a base 10 system, it adds up to about 6,000 years.
I'm not quite following that. Are you saying that the genealogy of these ancient myths goes back to about 6,000 years?
Oh, 6,000 years.
6,000 years from us.
6,000 years before the great catastrophic flood that many cultures record.
Okay, so there was a great flood 6,000 years ago. Okay, I have no problem with imagining that would be the case, or accepting that that's some evidence that was the case. But if we're talking 6,000 years ago, that there are epics or ancient traditions that talk about a flood 6,000 years ago, what would that have to do with the age of the Earth? Because, of course, the Earth could be a lot older than a flood 6,000 years ago.
Right. There aren't many cultures that have a specific number that go all the way back to the beginning. You mentioned the Hebrews, that's one. the Mesoamerican
Wait, back to
cultures.
the beginning of what? Back to
The beginning of the world. The beginning of
Well,
Earth.
but you're talking about ancient stories written down by people who have no concept of geological time, no access to carbon dating, not a very thorough understanding of tree rings and sort of scaling them back over time. And so the fact that they would not talk about a world older than the world that their religious texts said it was, when they have no access to science to contradict that, doesn't seem too surprising to me.
I understand that side of it. I'm saying that there are some cultures that put the two together, and that the evidences you brought out actually support my position.
So something like carbon dating would support that the world is a few thousand years old?
Correct. In fact, in radiocarbon, they listed a number of coal samples that were dated. They shouldn't be there, and using the most advanced method, which is the AMS method, that dated it, say, 40,000 years. Now, coal is often, hundreds of millions of years old. So just that fact, in other words, they almost have to say, well, it has to be contamination. Again, it's kind of an out, in my opinion. I believe the evidence is that since carbon-14 gives those dates, maybe the hundreds of millions of years is incorrect.
All right. So I'm no expert on this, but my understanding is that there's carbon-14 and there's carbon-12. Carbon-14 comes when solar radiation hits the upper atmosphere or something, goes into the air, is breathed into organisms, and then slowly decays back to carbon-12 over time. And the degree of its decay can be measured empirically and known ahead of time. And so the amount of carbon-14 that's left in a particular organism, and it only works with organisms, it doesn't work with rocks or anything like that, because there's uranium, which can cause decay as well. But so when people can dig up some organism or something that once was an organism, like, I guess, dinosaur fossils, or I don't know if it works with things like oil, I guess so, because it comes from trees, they can actually find out how old something is by using this carbon dating, figuring out what the ratio is of carbon-14 to carbon-12 atoms. And through that, knowing the half-life of the decay, they can figure out how old something is. Is that a fair way to characterize it? You've certainly studied it a lot more than I have.
Yes, but I would say that the coal is a problem because they realized that's what they were not expecting. So the only explanation they can come up with is the contamination theory.
I'm sorry, I'm not sure what the problem is. Are you saying that they have found coal that is relatively new?
It still has the radiocarbon in it, therefore they can date it. And when they date it for many samples, you get a date of less than 50,000 years. Sometimes as young as 40,000 years. And that's something you could do yourself. You could go to your nearest coal mine, ask for a sample. Of course, it involves some money, but I'm saying theoretically, anybody could do that, have a coal sample dated.
And what percentage or what proportion of the coal is dated relatively recently?
That I don't know, but in terms of the threshold of the measuring device, it's significantly above that. It's not just right at the very tip.
Well, no, hang on, dude. You've written a whole book about this.
Uh-huh.
Now, it seems to me that if 50% of the coal samples were dated relatively recently, it would be pretty hard to know whether it would be pretty hard to argue that that's contamination, right?
Uh-huh.
Because that's 50%. But if it's one in 1,000 or 1 in 10,000, then that could be that could easily be contamination, if that makes sense. So if you don't know the proportion, then it seems to me you're missing some pretty important information when it comes to your thesis, right?
Well, for that argument, I think you have a point that I haven't studied that aspect of it. It's just that in the journal, they didn't consider that as a possible explanation.
Consider what as a possible explanation?
That
the Earth is only a few thousand years old?
Yeah, that some of the samples were like a minority, but apparently it happens pretty often, is what I'm saying.
Pretty often. Again, I see, because I don't know anything about what contamination likelihood is in carbon dating, pretty often, it's a fairly important thing. So this is the first argument you've brought up, right? So it's fairly important to know what proportion of this coal samples seem to have the incorrect or impossible carbon dating. So my suggestion would be, you've got a book out there, you're probably going to put out a second version, that if you can say, well, 50% of the samples give this way too common, but if it's 1 in 10,000, then it's more believable that there's been some sort of contamination. Maybe when it was brought up from the ground, it brushed against newer stuff, and that kind of got mixed in. Or maybe, I don't know, someone touched it and it blended. I don't know what. Or maybe there's uranium around, which is causing accelerated decay of carbon-14 to carbon-12, or, lots of other explanations. But it would have something to do with the proportion of the samples that were giving erroneous results. So let's move on to another example of that. Of course, even if you say that some of the coal is carbon dated to only 40,000 years ago when it should be much older than that, 40,000, of course, is still a lot, as you know, past the 4,500 or whatever it's going to be. And how is that resolved? Or does that mean that the carbon dating is incorrect as a whole?
No, I'm just saying that that invalidates the hundreds of millions of years for the rock record, say, since the Cambrian, around 500 plus million years ago.
Wait, sorry. So are you saying that if there's coal found that dates 40,000 years back, that is found among rocks that are dated hundreds of millions of years back?
That I'm saying it brings that we should at least consider that as a possibility, since the Carboniferous is, say, like 300 million plus years ago.
Now, I just want to put this out here. A sample can be contaminated if organic material rich in fresh atmospheric C14 soaks or diffuses into it. Such contamination may occur in the ground or during the processing of the sample in the laboratory. However, such contamination will make the sample appear younger than its true age. Consequently, with reports to carbon-14 dating, it's a little tough to say that the contamination disproves it. Laboratories, of course, do have techniques for identifying and correcting contamination. There are various methods of cleaning the material, and the activity of each rinse can be measured. Lab contamination and technique can be checked by running blanks. A careful choice of the samples will often minimize contamination. Dating various portions of a sample is another kind of check that may be performed. So if the coal is even exposed to a bit of air from the surface, which of course would be much more rich in atmospheric carbon-14, then it can contaminate it. So it's not like that rare, because it's in the air sort of all around us, and so any exposure to air could contaminate the sample. So it's not that impossible for it to be contaminated, if that makes sense.
Right, but there are numerous examples, and in the article that was in the journal Radiocarbon, I think it was 1989, that they went through extreme efforts to try to create a blank, and they couldn't, because there was still radiocarbon within the sample, and there should be none after that length of time.
Well, again, I mean, I can't sort of speak to that, but they do have other ways of validating some of the carbon dating, right? So I'm sure everyone knows this, of course, a cross-section of a tree, because there's the rings, right? Because the trees are growing more in the summer and not growing in the winter, and there's different thicknesses because sometimes the conditions are better for the trees to grow. And so you can cut a tree, and you can count it back, and you can see the different pattern of thickness and thinness in the tree's rings. And then you can find an even older tree where the younger part of it matches the older part of the tree you already have. And you can kind of step back and match all of these tree rings to go back thousands of years. And my understanding is that they have been able to go back 8,000 years with these tree rings, and they can, of course, validate that with carbon dating, right? So they've found trees that they know for sure are within a decade or two of being 8,000 years old, and they can then measure the carbon dating in those trees and predict whether it's within the range of that which would be expected by the carbon decay, and they have found that it does match. So there is a way of validating the carbon decay. And of course, since the tree rings get back 8,000 years, that would be a bit of a challenge to the 4,500-year-old Earth. Right? It's almost double. I'm sure you've, of course, looked into that. And what are your thoughts about that?
Well, I would question the correlations, and sometimes an extra tree ring can go relatively fast. But when you break down these correlations, sometimes those can be off. So it's a little tricky, and I realize they try to add them together. But when you actually look at some of the oldest trees, just like a single tree, it goes back so many thousands of years. And that is actually one of my main arguments, and it has to do with tree rings in the fossil record. And there's a limitation on that, which would not be expected if the Earth is really hundreds of millions, or at least to the Cambrian, hundreds of millions of years that we're dealing with.
I'm not sure what that argument is.
Well, the thing is, if you look at the oldest tree that we have, it has about 800, a fossilized tree. It has about 816 rings. But today we have many, many trees with thousands of rings. Junipers, olives, bristlecone pine, of course, the redwoods and such. And if we look at the fossils that have the rings, the fossil trees, they've been around for 300 million years plus, but we don't find in the fossil record these trees with, say, 3,000, 4,000, or 5,000 plus rings.
Okay, so I'm not sure. Again, I'm not sure why. I mean, fossilized stuff is really rare.
Yeah,
as you know.
well,
Like I remember reading Bill. Hang on,
Go ahead.
still talking.
Go ahead.
I remember Bill Bryson was talking once about how rare fossils are. In that, if the entire population of North America went through the same process of fossilization, hundreds of millions of people, we'd find like one shin bone. That's how rare fossils are with regards to that. And so, the fact that I'm sure you're right, that they can't find fossil trees with thousands of rings. Well, I mean, fossils of any kind are extraordinarily rare. And of course, there may be some reason for that in terms of maybe those trees, if there was a fire, maybe they'd be burnt down. Maybe there was something in being underground for hundreds of millions of years that has caused the rings to decay. It's just possibilities. Again, I'm certainly no expert, but I would be a little skeptical about hanging my hat on that one. But go ahead.
Yes, there's the hundreds of millions of years that also help to give the fossilization a chance, since that's such a long period of time. And the other thing is, as we collect more and more, we kind of get an idea of how complete that fossil record is. And there was a book published specifically on that topic, the adequacy of the fossil record, that in general, the data is there. So like when Darwin wrote his Origin of the Species, he used that as kind of a out for why don't we find so many transitional forms. But today we can't really use that excuse.
Oh, this is the argument that says that you can't find transitional species. Is that right?
Yes.
Right. And I don't have the answer to that. I don't know if there is an answer out there that is accepted. But again, the extraordinary rarity of fossils. It's something that, we go to a museum and we see tons of fossils and we say, wow, it's a lot of fossils. They're everywhere. Or we see these, where they found these tar pits, where, the prey dinosaurs died there, and then the predator dinosaurs tried to come in and eat them and also got stuck there, and you end up with this mountain of bones. And it gives people the impression that fossils are somehow common, and they are, again, extraordinarily rare relative to the population of, say, dinosaurs and so on in the past. And so the fact that there aren't transitional species when there is an enormous number of missing fossils and so on is one aspect. There is some argument, and you can go to this website, transitionalfossils.com, which I don't think is necessarily I thought it was going to be a website devoted to the stripper's friend with the oxygen tent that we heard of earlier. But so it says here, all species undergo gradual change over time, but in the fossil record we find evidence of some changes that are particularly striking. These are called transitional fossils, of course, right? Mm-hmm. And so they're, I'm not even going to try this, these transitions, apes to humans, right? So there is Ardipithecus ramidus, Pithecus afarensis. Ooh, I'm very, very pleased with this going along. Homo habilis, I could do that, and Homo erectus. And so there are this one, the first one about 4.4 million years ago, had a brain the size of a chimp's, but possibly walked upright on the ground, was still able to go on all fours in the trees. The one that's 3.6 million years ago, a more advanced walker with non-grasping feet. I guess that's the big difference between chimpanzees and us, right? Non-grasping, one of them. But it still had the brain size of a chimpanzee. Homo habilis, about 2 million years ago, had a brain about 50% bigger than a chimp's, still voted for Bernie Sanders. The fossils are found with a variety of stone tools. The earliest humans were sure used tools 2 million years ago. Homo erectus, 1 million year ago, toolmaker, brain a size of about 1,000 cubic centimeters, still smaller than our own. Homo heidelbergensis had a brain size approaching our own, shows a mix of Homo erectus and modern human features. That's sort of one example. I won't go through all of these. There's fish, tetrapods, dinosaurs to birds, synapsids to mammals, land mammals to whales and dolphins, and proto-horses to horses, and then a bunch of miscellaneous one. And this goes on for quite, and there's, lots and lots of references down at the bottom. So, I don't know what is considered to be a transitional fossil. There certainly are transitional fossils. Of course, people can always say, but what about the transitions in between the transitional fossils? But of course, that's a god of the gaps and sort of a moving the goalpost example.
Yeah, there are many like that, and many evolutionists admit to it and then try to deal with it. In fact, my history of science professor, David Kitts, was famous for kind of pointing that out. But I would like to...
Sorry, pointing what out?
The fact that there are expected transitional forms and we do not find them. But again, that is a problem that, say, you have punctuated equilibrium and some other concepts. Maybe evolution occurred faster, and so we don't see the fossils. But I see it as a pretty critical problem. But
well, I think one of the things that I've sort of been reading about lately, and I've mentioned this book before, The 10,000 Year Explosion, is I was always taught that when I was growing up that evolution was slow, really slow. And certainly with human beings, it can be incredibly rapid, right? We've talked about and had an expert on the show about not the Sephardic, but the Ashkenazi Jewish intelligence that over a mere 700 years, or about 30 generations of selective breeding for intelligence, they have got a standard deviation higher. And with, of course, some instability and neurosis that comes with that high octane brain. But there has been incredibly rapid evolution, or evolution can be incredibly rapid. And of course, it's described in Richard Dawkins' book, The Greatest Show on Earth, which did actually surprise me about the degree of empirical validation that it does seem to be for evolution. But it can be incredibly rapid. It's not this, really slow process, but can be under pressure, can be extremely rapid. And so that may be, if you look at all of human history, if you sort of look, you can say, well, human beings sort of emerged in their prominent present form about 200,000 years ago. Then 50 or 60,000 years ago, there was an exodus from Africa, probably because of very loud music. And if you look at 200,000 years, well, that's obviously, at least not geologically, but as far as evolution goes, is a pretty large stretch of time. If you take 700 years out of those 200,000 years, that is absolutely, completely, and totally tiny. And so if you were to look at sort of Jews who weren't considered to be that smart in the ancient world and showed no particularly brilliant expositions or skills or abilities over the 200,000 year history of modern Homo sapiens, would you find necessarily the brain development that has gone into Jews over the past 700 years? Well, it would be very unlikely if out of all of North America, you're only going to find one shin bone in the fossilized record. So the fact that evolution can happen very quickly and that there are massive natural gaps just because it's so rare is not too shocking to me.
Well, I like to emphasize the overall picture of like biological essentialism, like that Aristotle held to, and man's unique character. Like when Hamlet says, "What a piece of work is a man." And those unique characteristics, like you talked about, walking on 2 feet and some of these other things, because man it really stands out. And like say when Noam Chomsky talks about the uniqueness of human language, I think those are things that a lot of people realize that that's a big gap. But if the gap between man and the animals is large, maybe each individual essential type of life, there's also a big gap.
Well, I mean, I certainly agree that I would not want to be having this show with the phytoplankton because it would be, kind of one-sided. So human beings are like nothing else in many ways in the entire universe. And it's not just like, lots of animals communicate and all that. But human beings, especially with concepts, with abstractions, and again, you can see some primitive stuff with this with some animals, but the degree to which human beings' mental capacities outstrip other animals, well, it's just why we've become the dominant species on the planet, to the point where we pretty much own or control every other life form on the planet in one form or another. And so I completely agree with you that human beings are like a weird, unexpected plus. But it simply turns out, I've sort of made the argument, which is not biological, but it's just, I think, pleasing, if that makes sense, that particularly in colder climates where you have winter and you have to defer gratification or die, if you live in a place where food is fairly plentiful, but there's random dangers, then you get with this R-selected stuff. But in colder climates where you do have to defer gratification, not eat your seed crop, and do a lot of work which doesn't pay off for a year or more, sometimes you go clear a plot of land and you got to plow it, you've got to plant it, you got to fertilize it, and it may be 2 years after you start that you get something out. And so to me, the deferral of gratification and the additional calories provided by agriculture per acre, like hunter-gatherers, like a small tribe needs thousands of square kilometers to roam around in, and it's very hard to survive, which is why the human population never grew very large. And 70,000 years ago, according to some reports, there was a series of volcanic eruptions. I don't know, maybe some giant meteor hit somewhere. A series of volcanic eruptions that reduced the planet's temperature so much that the entire human population was reduced to about 10,000 people, some in India and some in Africa, I guess the last warm places on the planet. And so the deferral of gratification is so essential to surviving, particularly in a cold agricultural environment, that it's like the brain reluctantly developed intelligence because that's the only way you can get to the deferral of gratification, which is not just the foundation for survival in a agricultural society, it is the foundation for civilization itself. If you can't defer gratification, you can't have civilization. And so the fact that human beings developed enough cranial capacity to figure out agriculture, which then in turn rewarded so enormously those who developed additional intelligence, and we're talking like 10,000 years ago, which is a tiny slice. And so it's still only 5% of the length of time human beings have been alive, and a tiny slice, of course, a minuscule slice in the history of life, let alone the history of the planet. But the fact that the deferral of gratification is so rewarded and so stimulated in a relatively free market, non-welfare state environment, that human beings would have ended up with a 10,000-year evolutionary pressure on the deferral of gratification, which is the result of intelligence, that there would be such a positive stimulation for selecting for intelligence that we would end up with sort of the modern mind. It's an incredible story and a pretty remarkable development, but I think falls well within the parameters of what would be encouraged or supported by evolution. Okay, that's the end of my speech. I'll let you talk from here.
What is your opinion on the intelligence of Neanderthals?
Well, I don't know. I mean, I was always sort of raised to think of Neanderthals as our historic low-rent cousins from the wrong side of town. But I've heard some arguments that Neanderthals were more advanced than we thought. But then in particular, the blend of Homo sapien and Neanderthal DNA with these low-rent, biological cousins screwing wastrels and reprobates from history, that the mixture of Neanderthal and Homo sapien DNA gave rise to a particularly potent form of intelligence within Europe, which is, of course, has done so much for the world, for good and ill, over the past 2,500 years. So I do think that there does seem to have been some more advantages or greater intelligence to Neanderthals than I was first told about when I was younger. But in particular, the breeding combination, the wider the gene pool that you can breed with, the more advantageous mutations you can get. And so maybe the mixture of Neanderthal and Homo sapien DNA produced sort of the modern European species of intelligence. That's what I've heard. Again, I obviously can't verify, but that's my thought.
Well, the figure I've heard is that up to, at least for non-Africans, up to 4% of our DNA come from Neanderthals. And I make an argument. We were talking about population earlier, and again, there could have been some disasters. I admit that. But I make an argument from the population growth of Neanderthals. Supposedly, they started around 300,000 years ago, and they left around 25,000 years ago. So if you kind of set that time frame and assume just 1/100th% of a population growth, you come up with 27 trillion, which is kind of a lot. And
wait, I'm sorry. Your argument is that with a smaller early population that you might have some sort of linear population growth?
Exponential. I'm using the exponential formula.
Oh, sorry. Yeah, sorry.
Number.
Sorry.
Right.
No, you're right. Sorry. Linear in terms of a certain percentage increase every year. Exponential in terms of the actual number. Okay.
Yes.
But that's not how. I mean, you know this, right? That's not how life works. Life will expand to exploit the available resources, but when it runs out of resources, then it has to stop expanding because it can't feed its young, right? So there's no way that population would ever increase in a linear fashion. You could sort of say, well, prior to the modern age where we're much better at getting resources out of nature and exploiting them for human consumption. But the fact that the population remained relatively low is because hunter-gathering was incredibly inefficient relative to modern farming. Ancient farming was incredibly inefficient relative to modern farming, and there just weren't enough resources to sustain a growth in population. Otherwise, we'd be like moon deep in rabbits right about now. But the rabbits run out of stuff to eat.
That's exactly my argument. And the Neanderthal range is much wider than a lot of people are aware of, from Spain to England, to the Middle East, to near Mongolia. So they're all over the place. We have a lot of, not tons, but in terms of their geographical distribution, there are a lot of Neanderthals. We know they bury their dead in a ceremonial way, and they were quite intelligent. They made this one kind of glue for their spearheads. I think it was from a sap, but it was heated so hot to get it to stick like they did that we haven't quite figured out how they were able to produce such a high heat.
Okay, so there were lots of Neanderthals, and then I would assume that the Homo sapien Neanderthal hybrid was better at war or better at exploiting resources, and therefore drove out and demolished the, two subspecies generally don't inhabit the same geographical area, right? You get a bunch of gray squirrels moving in, and the red squirrels move out. So two subspecies don't generally inhabit the same area. And since Neanderthals and Homo sapiens would have been competing for the same resources, I would assume that the Homo sapiens were slightly better at something. And in particular, the Homo sapien Neanderthal combo was even better at those things and displaced both of the originals.
That's possible. All I'm saying is that given even very tiny population growth, the time frame seems wrong for the length of time that Neanderthals lived and considering their intelligence.
But there is no such thing as linear population growth in an environment where the resources are somewhat fixed, right?
Well, that's why I'm using such a small number. In the 60s, we had a pretty big population growth. In about 2009, I think it was a little over 1%. So I'm using not 1%, but 1/100th%.
No, but it still doesn't matter, because it doesn't matter how small the growth is. It can't possibly be linear because you bump into the edge of resources, right?
Agreed. But I'm saying even assuming natural disasters, sicknesses, and whatnot, the lower population growth helps to account for that on average in the long run.
No, it doesn't. Listen, let's say that you have an island with 1 square kilometer. It's a 1 square kilometer island, right?
Yes.
Then you can't put 1 million people, outside of Hong Kong, right? You can't put 1 million people with ancient technologies on 1 square kilometer island and have them survive, right?
True, but their range is a huge part of the globe. the Neanderthal range is
No, it
large.
doesn't matter. What I'm saying is that it doesn't matter what their range was. With the technology available at the time, they could not extract much food from the ground, right? Especially in a place where there's winter, right, where it's really hard to find food. And so because certainly hunter-gatherers cannot exploit enough resources to grow beyond a few dozen members, maybe 50, maybe 75. And so you say, well, if we just assume that the hunter-gatherers grew by a hundredth of a percentage every year or whatever, but that's not how it works. They grow until they can't get enough food to feed their young, and then the population tends to stabilize. Now, if they figure out some way to get more food, like once they figure out agriculture as opposed to hunter-gathering, well, you get more food per calorie expenditure, then you can get a population increase until you run up against those limits. And then maybe you figure out crop rotation, maybe you figure out manure, maybe you figure out how to plant winter crops like turnips and so on. Like, there's a bunch of different, maybe you figure out, hey, we can drink this weird white goo coming out of the teats of the cow. We can be vampires. So it grows until you run up against the edge of your resources. There's no such thing as it just continues to grow, taking into account disasters and so on. Once you run out of resources, you can't grow until there's some technological advancement. And even then, you grow until you've reached the maximum amount of your resources, right? I mean, you have a really great harvest, right? And you maybe have twice as much food, and everyone's like, great, let's go make some babies, right? But then next year you have a drought, and then half your babies die, right? Because you just don't have enough food. So even if you grow to the limit of your available resources, the circle that you can grow into is expanding and contracting all the time. Even if you're getting better at it, it'll expand maybe 10% one year because you figured out something new, but then next year you get a bunch of locusts or some crop rot or something like that, and it contracts 20%. And then you maybe get another 10% further back out. So it is a very unstable carrying capacity whenever you're dealing with particularly ancient technology. So I don't see how you can get even if I apply a very small number, it doesn't account for it. I just don't know how you can apply any number outside of what the carrying capacity of the environment is.
Well, I'm not a Neanderthal expert, but what I'm arguing is that their wide geographic range, it gives evidence that they had the survival problem somewhat solved.
Well, until they died out, in which case they didn't have the survival problem solved. Right?
Yeah, but that's a time period of 275,000 years.
Right, and they would grow to the carrying capacity that they could figure out how to get from their environment, and then they would stop growing. Anyway, let's move on. I think we both made our case with that, but if you wanted to bring out something else, that would be fine.
Oh, sure. One thing is, on the rock record, we find sometimes amino acids, and amino acids for life are predominantly left-handed, but over time they break down to left-handed and right-handed to pretty much it's a 50-50 mix. But throughout the
I don't know what left-handed and right-handed means.
It's like if you connect your Tinker Toys that you might have used in a chemistry class. Of course, now we do it with 3D animation, and say what coffee looks like, and you make a chemical diagram of it. If you take it and you flip it over, that would be kind of the mirror image. So if you look at your left hand and your right hand, there's an arrangement to the parts. So certain amino acids have a left form and a right form. So in nature, in living things, they're virtually all left-handed. But over time, just left alone, they'll start to decay, in a sense, to a mix of about 50-50. Half of it will be the left-handed form, half of it will be the right-handed form. As if you put a big pile of left-handed gloves in a box, you come back a year later, and half of them are left-handed, half of them are right-handed, something like that.
All right.
So we find in the rock record that there are some that haven't completely got to that point, even though the process didn't take all that long. And again, it's explained away as contamination. So that's just one aspect in terms of the rock record. And the name for that, if you want to research it some more, is just racemization. That's the name for that kind of dating method.
Okay, a bit of comment here. Researchers analyzing meteorite fragments that fell on a frozen lake in Canada have developed an explanation for the origin of life's handedness, why living things only use molecules with specific orientations. The work also gave the strongest evidence to date that liquid water inside an asteroid leads to a strong preference of left-handed over right-handed forms of some common protein amino acids in meteorites. The result makes the search for extraterrestrial life more challenging. Oh, bummer. This is a quote from Dr. Daniel Glavin, lead author of a paper on this research to be published in the journal Meteoritics and Planetary Science. Quote, our analysis of the amino acids in meteorite fragments from Tagish Lake gave us one possible explanation for why all known life uses only left-handed versions of amino acids to build proteins. And we'll put a link to this. And listen, I mean, I have obviously no problem whatsoever with your skepticism. I think skepticism is fantastic, Jay. I guess it just seems like the skepticism is kind of one-sided insofar as I think it sounds like you have a thesis that you want to prove that the world is a couple of thousand years old, and you're very skeptical of even the slightest evidence that goes against that. But of course, there is a lot of evidence that goes against that, and I'm not sure that you're skeptical as much of the evidence that you are claiming supports it, if that makes sense.
No, I understand that, and that's an idea that before radiometric dating, there were all sorts of viewpoints. Even some well-respected scientists, say in 1900, thought the Earth was just 10 million years old. And of course, Lord Kelvin's argument about the heat of the Earth, in his last estimate was around 24 million. And often we accept, kind of an argument from authority. Well, a big scientist says it, so I will accept it. And in fact, Mark Twain basically said that. Well, Kelvin's the top scientist. I'm going to go with what he says. But what's interesting is many people think that what threw out Lord Kelvin's argument about the Earth is cooling off, and we know, like, you take a hot ball of iron, we kind of know how often it takes to cool off. He took those laws of physics and extrapolated it to come up with that date. But it's very seldom realized that the person that his name was Perry, who actually had the correct argument against it, wasn't radioactivity. It's the fact that just like you churn your soup to kind of cool it off, it's the convection inside the Earth. And he mentioned that in the late 1800s, but many people kind of overlooked what he had to say. So it's like there was a bias against accepting Kelvin's date, because how could evolution happen that fast? And even in Darwin's 6th edition of The Origin of Species, he wrestled with that. So he adopted Lamarckism, and even to some extent adopted a form of catastrophism, that a lot of things happen more rapidly, both geologically and biologically. So, in other words, I've seen this story before, that the argument for the old Earth is just the zeitgeist at the time, and people accept it without considering alternatives.
Well, but I mean, this was prior to a lot of the modern techniques for doing dating, right? This is prior to carbon dating and so on. So talking about 19th century scientists and the fact that they would have been incorrect in underestimating the age of the year, it seems perfectly relevant to me. But of course, the time frame has been getting longer, not shorter, right? And of course, if the time frame had been getting shorter, then it would be an argument for the Earth being younger than, of course, 24 million. But it's going the other way. It's getting longer and longer and longer, right? To now where the Earth is, I don't know, what is it, 4.5 billion years old that it's considered to be. So it's going the wrong way to where you want it to go with additional measurement. And I'm wondering how you tackle that.
Well, it wasn't actually until 1929 that a scientific organization basically gave the thumbs up for the radiometric dating. And the paper was written by Arthur Holmes, who wrote like 70%. So to an extent of that report. So to an extent, you can put a whole bunch of why radiometric dating is so big to Arthur Holmes. But one of the early...
Well, no, hang on.
Go ahead.
It's not just some guy who made it big, right? It's the fact that it seems to be quite accurate to the degree with which it can be verified with other dating metrics, right? So, I mean, as you know, right, sedimentary layers in the Earth are all considered to descend in terms of age, right? So as you descend in sedimentary layers in the Earth, you ascend in time ago, years ago.
Correct.
The lowest to the oldest, right?
Right.
And so when carbon dating is done, first of all, there is, based upon some rough estimate of what the age is, you should have a range that the carbon dating is going to work in. The carbon dating can be verified at least 8,000 years back with the tree rings and so on. So it's not just, well, some guy made it popular. It's not like Pringles. It is something that has a lot of independent, or I guess you could say at least cross verification to it.
Well, the early researcher, one of them was John Jolly, and he had his preference on the age of the Earth, which was much younger, based on the salts in the ocean. Maybe you're familiar with that. How long would it take to accumulate the different salts that are in the ocean? But he was one of the early researchers with radiometric dating, and some of them are inconsistent. And I give numerous examples in my book about that. Sometimes the different methods are hundreds of millions of years different. But if we start, as you did, with the carbon dating, I have a quote in my book, because we can use carbon dating for historic objects, that before 400 BC, it really goes wonky, and it's not as accurate. And again, my argument about the tree rings would be, I believe there are flaws in the correlation. And if we just look at single trees, those only go back thousands of years.
Okay, so if you are opposed to arguments from authority, which is sort of what you're talking about, that we shouldn't just take what the scientists say as valid. And I agree with that. I mean, all science, as Feynman said, is based upon skepticism of authority. Okay, so would you not say, though, that given that it is a religious argument that the world is thousands rather than billions of years old, that is also an argument from authority? It's just an argument from textual authority believed to be inspired by God, right? Is that also subject to the argument from authority rebuttal that you've applied to the scientists?
Right, but I'm also using, like I said, some of the ancient traditions as well as the scientific evidence. So the idea that we don't
ancient
have
traditions are, look, man, come on, you can't. Ancient traditions are not sources of objective knowledge, right?
Well, I'm saying if they recorded the history correctly, I'm claiming that the Babylonian king list is probably close to reality. That's actually what I'm claiming. And others similar to that.
Okay, but before, like when they started writing down things as far back as they can remember, you can't just say, well, after that, the planet wasn't there, right? That's like saying if I get hit on the head and can't remember anything from before yesterday, the planet was created yesterday, right? I mean, just because people's memories don't go further back, given that memory was also evolving along with the brain as a whole, you can't say, well, they can't remember any further back, or they haven't got any records further back, and therefore there was nothing but void, right? I mean, just as far back as their memory and records could go.
Well, some cultures put the two together at the beginning of the world. In other words, say the Mesoamerican cultures specifically do that, not just the beginning of humanity.
Put what two together?
The beginning of humanity and the beginning of the world itself.
I get it. That's the religious argument, that the world was created by God for people, with people, at least two people in it to begin with. I understand that. There are lots of religions that believe that humanity was created at the same time or shortly after the earth. But saying that this is some sort of proof, there are lots of religions that have like elephant-headed blue deities with like 6 swords in 6 arms. That doesn't mean that we've got to put something new into the Encyclopedia Britannica of biological organisms.
What I'm saying is it's a possibility, and it's a starting point that leads to some interesting scientific investigations.
It is not a starting point. It is not a starting. Like, ancient myths are not a starting point for scientists, right?
Well, there's a whole book.
Otherwise, you'd say to biologists, well, go read about dragons, and then that's a starting off point for scientific exploration of dragons. It's like, no, unicorns, or I don't know what, fairies, leprechauns. Right? I mean, I don't mean to make fun of you, but the dryads that live in trees believed in by the Druids. I mean, you don't go to an arborist and say, well, let's go and find these because there was an ancient myth about it, so let's start a scientific investigation from that. Where else would you put this? Would you look for tooth fairies?
No, I'm Native American. Just to give an example from a Native American tradition, when the governor of the Louisiana territory. He confronted some Native Americans, and they started talking about the Yellowstone region. And they says, oh, yeah, it's a volcano. But the last volcano was 70,000 years ago, volcanic eruption of Yellowstone. There was a huge one that gets a lot of attention, and you may have heard of this. It was about 600,000 years ago. But there was a more minor one that is, by mainstream dating, is about 70,000 years ago. And there is also a book, Mythology and Geology, and puts the two together. It's published by the Geological Society. And there was an island, I think part of Fiji, and there was, again, a volcanic explosion, a volcanic eruption that created an island, say similar to Surtsey. And the natives had a tradition that an island just pop out of the water and within their great-great-grandparents' memory. But yet, according to the standard dating, it was something like, I forget the exact number, but maybe something like 30,000 years ago. So what I'm saying is these ancient traditions have validity.
No, but not when they contradict the basic facts of reality, right? So when people say, well, first of all, this thing that 70,000 years ago there was a volcano, that could be coincidence. I'd want to see a whole bunch of those examples. And even if we said that was true, okay, maybe there was something handed down in tradition for 70,000 years. Lord knows that the Native American culture did have a little bit of staticness to it for quite some time. But a volcano is not something that contradicts the basic facts of reality. Like if they said there was a volcano floating in the air, that would be different from there was a volcano there, or there was an island that came up out of the ground. Now, if they said there was an island that slowly floated down from the sky, pulled by unicorns and dragons, we wouldn't say, we better start examining unicorns and dragons bringing giant islands down from the sky. So it's one thing to say there are ancient traditions that may describe things that are perfectly possible or at least plausible within reality versus ancient traditions that vehemently contradict the basic facts of reality, like the ancient tradition that the world is 4,500 years old or something like that. Those are two very different categories.
Yeah, I'm not proposing that there's islands in the sky.
Okay, so then how do you overcome the carbon dating, the geological record, all the stuff that indicates an extremely old universe? The fact that they can even figure out how old the sun is, the fact that there are light years that go way beyond 4,500 years. Like they can detect things that are more than 4,500 years ago, which means more than 4,500 light years away, which means the light must have been traveling for a long time. I mean, everything kind of points to one thing, and you'd have to explain away all of those. And seems like a pretty impossible task to me.
Well, there are those that realize that there's weaknesses in evolution. Often I get a better response from the historians of science and the philosophers of science. Alexander Bird, he's a philosophy professor at the University of Bristol, and he did not endorse my book, but I quote him on the back. And basically he admits, well, how do we know the Earth is old? Well, look at the rocks. They've been dated. Well, how do we know that? Radioactivity. Well, what does that depend on? The radioactive decay rates and such. And so there's a weak hypothesis. And so,
wait, no, hang on.
Go ahead.
Why is that a weak hypothesis?
Because the radioactive decay rates can change based on, say, the solar activity can have an effect on it. And there's evidence that the solar cycle was actually more frequent in the past based on tree rings.
Yes, but you can't jump from imperfect to impossible. Right, this is what people frustrate me, and I'm sorry to take this out on you, man, but people frustrate me when they say, well, science isn't perfect, therefore unicorns. Science isn't perfect, therefore impossibilities can exist. Of course science isn't perfect. It's an empirical discipline. There's going to be holes, there's going to be problems. This is why science at its best is skeptical and is hypothetical, right? But the idea that because science can't perfectly describe everything, I get to have my pet invisible unicorn is not valid. That is not how rational thinking works. So saying, well, there's incompleteness in the fossil records, and therefore I can make up whatever I want about past and the history and the future, and I can have mythical descriptions of the past be somehow objective, verifiable information and so on, chipping away at the imperfections of science is exactly what science does. So the fact that scientists have been wrong in the past, of course, that's exactly how science works. But the fact that scientists have been wrong in the past doesn't mean that people then get to say that whatever crazy theories they come up with could also be true because scientists have been wrong in the past. The question is, Jay, and it really comes down to this, are there any standards by which your hypothesis of the young Earth could be falsified? Tell me how it could be falsified. In other words, what standard of proof would you accept to abandon the thesis?
Well, if we could invent a history observation device, not a time machine. I'm not going Dr.
No,
Who on
no,
ya.
come on. Come on.
But
That is plausible within the framework that we're working in, right?
yeah,
Time travel is not possible, to my knowledge,
Well,
in any
it's different.
practical sense or in
It's
any practical way. Give me something, because that's a ridiculously high standard, right? And it's not a standard that you're applying to evolution. With evolution, you're saying, well, there are a couple of holes, so maybe we can just toss out the whole damn thing. Or you're saying, well, maybe there's some uranium in the ground that screws up some carbon dating, so let's just toss out the whole damn thing. You can't have really low standards for disproving scientific hypothesis and then demand a time machine to disprove your own hypothesis. Give me something that you would accept as proof within the current context of science that your hypothesis of a young Earth was false.
well, there's a distinction between historical science and if we go into the chemistry lab and really break bad and blow up the laboratory. So there's certain things we can experiment today and repeat them, and anybody across the world can repeat it. But in terms of the past, we can't recreate continental drift in the laboratory. We have some very good theories and proposals, but to get a certain aspect of the past, we're giving reasonable evidence that shows that this is possible and this could have happened. What I'm saying is it is possible that the Earth is young. I realize that the standard theory goes against that. I understand that. But I'm just saying there are pointers and there are evidences that it's not proof, but they lead us to the idea that this isn't such a crazy idea after all.
You didn't answer my question.
Well, outside of the history observation device, which has been written about, of course, in science fiction, I don't know that it's possible or not, but I'm just saying that sort of a thing would give us a more sure verification of it. But I'm saying because it's historical science, it's not absolute proof at all.
So you have no standard in the present by which your hypothesis of the young Earth could possibly be disproven.
Well, if we found, say,
yes or no, just yes or no, man. Come on, don't filibuster me.
If
just
we
yes
found trees with, say, 100,000 rings in it, that would be a very strong indicator.
Trees don't live that long. Try again. Trees don't live that long. Try again.
Well, that's the point. The fact that the sequoias live so long, they seem to be almost impervious to everything, seem to indicate that there must have been some great catastrophe that wiped them out. That's exactly what I'm arguing.
No, trees don't live to be 100,000 years old.
Well, that's
right?
A claim.
What?
In other words, what I said was 5,000 or 6,000 years. We don't find those, or even like I said, 816 rings. That seems to be the oldest one.
Okay, so what I'm getting, Jay, is that there's no standard by which, with any current technology that's not currently Jetson-based, that there's no standard by which your hypothesis could be disproven. In other words, your hypothesis is immune to disproof.
I would not phrase it that way.
It has nothing to do with science.
I would say that it's in historical science, we have indications, but we don't have proof. A good indicator for an older Earth would be a fossilized tree with multiple thousands of tree rings. I won't go to 100. I just gave the extreme to prove the point.
Okay, so an organism that has never existed to anybody's knowledge is what you would accept as evidence for. So
we can
you have a very, very high standard of proof. Sorry, you have a very, very high standard of proof required for scientific theories, right? Despite all of the evidence that conforms geologically, biologically, and so on with the multi-billion-year Earth. You chip away at those little things and you're willing to take pure skepticism because those things aren't 100% proved. But when it comes to disproof of your thesis, You need 100,000-year-old trees and time machines. You see that there's a real imbalance there, that there's the level of proof required for the scientific theories is extremely high, and the level of proof required for your theories doesn't even exist. Like, you just have to accept that it's true because apparently people wrote down Babylonian king lists thousands of years ago. You get that that's a ridiculous double standard, and it's extremely hypocritical for you to be very skeptical of science while advancing your thesis, which has no support empirically. Like, that's just a very huge double standard that you don't. I'm not going to change your mind. This is for the audience, right? You're obviously fixated on this probably for religious reasons, but I just want people to see that that's a ridiculous double standard to say the science has to be perfect. But to disprove mine, you got to have 100,000-year-old trees and time machines.
Well, a history observation device is different. But I gave several examples, a juniper, an olive tree, a bristlecone pine, the giant redwoods out in California. There are many trees right now we could go visit. Some you can drive your car through. I'm sure you've seen the postcards. So they exist right now in the real world.
And those trees and those tree rings are what lead you back past 4,500 years, right? To almost double that. So already the Earth is almost twice as old as a lot of the young Earth people think, if the trees are important.
Well, I'm questioning the confirmation by radiocarbon, and I'm questioning the correlation methods. Because sometimes you have fewer tree rings, sometimes you have more.
No, you're not questioning. What you're doing is sticking your hands in your ears and going la, 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 la. You're not questioning. Because the first thing that you came up with was skepticism around carbon dating, and I asked you what percentage of these things were incorrect, and you didn't even have that answer. You're avoiding examining the question. You're avoiding the basic requirement to examine the question, is that their statement is, look, the air contaminates carbon dating, so of course we're going to get some misreadings because air is kind of everywhere up here. And so you don't even know the proportion of, quote, false or contaminated readings out of the carbon dating. So saying that you're being a skeptic is not an accurate portrayal of your position. You are very much emotionally, intellectually, theologically wedded to the young Earth, because that supports the theological view of when God made the world and when God made the universe and when God made people. And maybe like the flat Earth guy, it makes you feel special to be a glowing child created by a deity or whatever. But the idea that you're being a skeptic is not true. I mean, you're not being skeptical. You are pushing away a narrative that threatens you emotionally, which threatens your faith. It's nothing to do with skepticism. You're simply wedded to, and I've given you good opportunities to explain yourself, and if you listen back to this, you'll realize just how incomprehensible your arguments are. But you are emotionally wedded to a particular worldview, but the idea that you're going to climb up on some scientific mantle of skepticism and say, well, I'm just being skeptical, that's not even remotely accurate to what you're doing.
Well, I would just challenge those that have the wherewithal to go to their nearest coal mine and have a sample dated. Again, make sure that it's not contaminated. Go through the established procedures, use the AMS method, and I predict a date of less than 50,000 years. All
right. Well, I guess if anybody wants to go out and spend the tens of thousands of dollars to try and find out if the Earth is 50,000 years old, which is still more than 10 times the estimate, people can go and do that. But listen, I really appreciate the call in. It is always fascinating to speak to people who have a very different perspective from myself. And I appreciate the call. And I guess we'll just do one last caller. Thanks very much.
Thank you so much.